Hi, welcome to the series of ASPICE learning sessions. I am Tota Krishna Hema. So I am your ASPICE expert or the Automotive Quality SME. So in this session, we would like to see uh, about ASPICE introduction and its overview. What is ASPICE? ASPICE stands for Automotive Software Process Improvement and Capability Determination. How it is initiated, how ASPICE is initiated is by the time like ISO has multiple standards, the European automotive manufacturers or OEMs thought like let us develop something which is very confined to the automotive industry. So they have picked ISO 15504 framework and they try to put in all the essentials which are required for the automotive industry. So who are these OEMs? So there is a particular group called special interest group. So there are 11 car manufacturers. So those are Audi, BMW, Daimler, Fiat, Ford, Jaguar, Land Rover, Porsche, Volkswagen, and Volvo. Altogether, they formed as Automotive Special Interest Group. And they took another ISO 32020 as the process assessment model reference. Means like they have picked up the assessment concept or the process capability concepts from the ISO 30020. The results of assessment are used in identification of process improvements at the supplier as well as the criterion for supplier selection. What is the benefit? So as a manufacturer, so there are two sorts of things, like one is the original equipment manufacturer or the automotive company, and the second thing is a supplier for the OEMs. So what is the benefit which the OEM get and what is the benefit which supplier get? So by implementing the ASPICE in their particular environment, OEMs can control the quality in electronics and software, especially as a product and supply chains becomes, it's like it was very complex and it is easy now. The management of risks and problems that arise in the supplier project in order to meet the tight schedule, especially with ever shorter development cycles. So it helped in managing the risks and issues associated with the tight schedule with the OEM. So one thing is, so it helped in monitoring the supply chains, and the second thing is it helped in managing with tight schedules and the risks and the risks, opportunities, problems, and these all they can manage altogether with the help of ASPICE. And wherein suppliers participating in, so when they get ASPICE certification, so they will get more and more contracts from the OEMs. So that's the first one, and the second one is like to the control of development cost and the quality problems in volume production caused by development, leading to recalls. So what is the ASPICE benefit in terms of management visibility? There are 5 different levels of ASPICE. So in level 1, which is called performed, so project looks as black box. So we can't, there is some input going and there is an output coming out of it, but it looks like a completely unknown thing. So level 2 is a managed one. So even though the individual projects or the milestones or the release level approaches are looking like black box, there is some idea like when to release, what to release, something like that. And level 3 is established. It has some process which is in place. So you will know what is happening inside the project, and each and every release or milestone inside what exactly it is happening. In level 4, it is predictable. We have sub-process or sub-categorization of processes, so we can ensure on like by when we can deliver this particular project, or by when we can deliver with the 100% scope adherence. So this is what we can get in level 4. In level 5, it is which is called optimizing. So we will be working on the continuous improvement of the process. So this is a management visibility, wherein the development quality. So in the level 0, it is defect. So the defect injection is causing some, it may end up all your budget as well. So by half of the, by coding and unit testing time, you will end up all your budget, maybe something like that. So in level 1, so the defect costs you around $4,000. In level 2, defect costs you around 2500, or level 3 costs you $1,400, and level 4 costs you $1,000, and level 5 costs you $800. Because so the distribution of the defects in the development cycle, so it is by moving from level 0 to level 5, the cost of fixing the defect or identification of the defect. So since we are identifying and we are able to control the process, so the defect fixing cost is reducing. So ASPICE assessments, so there are two different assessments which are the major category is internal assessment and the external assessment. Internal assessment is carried out by the internally identified ASPICE expert. So assessments to identify actions for process improvements. So here we will get the process profile you can see that. So in terms of external, so external is assessment carried out to establish the capability of the project. So either it is by the customer, something like customer, or the audience, so whoever gave the project, and the ISO, or the service provider, or the external assessment person, so who came and gives us the level. So there in process assessment, so there's another division called the process reference model and the process assessment model. What is process reference model is describes you like what is the process, best practices and outcomes, wherein the process assessment models describes how to measure this. PRM is about what is done, and PAM is about how it is done. Process reference model in detail. Processes are grouped by process categories and its second level into process groups according to the type of activity they address. There are three process categories: primary lifecycle, organizational lifecycle, support lifecycle processes. Each process is determined in terms of purpose statement. The purpose statement contains the unique functional objectives of the process when performed in a particular environment. For each purpose statement, a list of specific outcomes is associated as a list of expected positive results of the process performance. So coming to the process reference model, so as we discussed, there are three different categories. So in primary lifecycle processes, organizational lifecycle processes, and support lifecycle processes. So in primary lifecycle processes, there are further four segregations. So one is acquisition, ACQ, supply process group is SPO, system engineering process group SYS, software engineering process group SWE. Four different ACQ, SPL, SYS, SWE. So coming to organizational lifecycle processes, we have management process group, process improvement process group PIM, reuse process group REU, support lifecycle processes supporting process group SUP. We have altogether three basic categories, and in that it is further classified into 8 different categories, 3 into 8. Okay, so there is another concept called, we have some German car manufacturing companies or car makers, so they have formed a group called VDA. So VDA called Verband der Automobile Industry. So this group is picked up some process areas and they have prioritized in order to implement that. Those are the important or the crucial or the mandatory process areas which we have to look first, and then later on, based on the applicability of the project, so we can go for the next. So this is the VDA scope. So the entire process areas are like this. It is expressed in this way, but wherein you can see this red marked things are VDA scope process areas. So for the better understanding, so I have grouped up all the VDA scope into one slide. So there are overall 16 process areas in VDA scope. So as in ACQ, we have supplier monitoring, ACQ 4, that is only one from ACQ, management process group. In that we have MAN 3, so that is project management, that is one. And we have system engineering process group. In that SIS2, SIS3, SIS4, SIS5, SIS software system requirement analysis, system architectural design, system integration and integration test, and system qualification test. So altogether 4 from system. And from software engineering process group we have 6 together. Software requirement analysis, SWE1, SWE2 is software architectural design, SWE3 software detail design and unit construction, SWE4 software unit verification, SWE5 software integration and integration testing, and SWE6 software qualification tests. Altogether 6. And support process group we have SUP1 quality assurance, SUP8 configuration management, SUP9 problem resolution management, SUP10 change request management. Altogether 4. So the total or the grand total of this process areas of who are in the VDA scope is 16 altogether. Yeah, we have come up with the VDA scope and the process reference model. Coming back to the process reference model in detail. So the process reference model, what it is like we can see this, like we have a process ID, process name, process purpose, process outcomes, best practices, output, work products, and there are some nodes which belongs to the process outcomes and the best practices. So this is a reference model, so which we can refer to. This is a sample which is given from MAN3 process area, that is called project management process area. So we can skip this, so we have already discussed this thing. So in process assessment model, there are 2 different indicators: process performance indicators and process capability indicators. Process performance indicators exclusively for capability level 1. So indicators that the extent of fulfilling the process outcomes. Types of process performance indicators are best practices and the work products. So process performance indicators are specific to the process. So for level 1, so we have to assess for process performance indicators. For process capability indicators, so that is from level 2 to level 5. So it provides an indication of process attribute fulfillment. So they implement the indicators of generic practices and generic resources. So altogether we will get an evaluation from level 2 to level 5. Process capability indicators apply to every process. As we discussed before, there are 5 different levels of ASPICE. So level 0 is incomplete, level 1 is performed. It has the process area. 1.1 is process performance, level 2 is managed, performance management and work product management comes into level 2. Level 3 is established, process definition, process deployment comes into level 3. Predictable, process measurement and process control will come into predictability. And level 5, optimizing. So process innovation in process optimization comes into level 5. So level 1, 2, 3 explanation in this one picture is level 1 is activities performed where products exist. As it's like there's a little chaotic there. In level 2 we have performance management and work product management. So performance management is like we have estimates, plan, schedule, monitor, status reports, resource management, improvement objectives, project metrics in place. In project level, particularly level 2 is about project level. So in project level, we will have the work product management, we will have configuration management plan and the naming conventions, templates, checklists, reviews, all together project level. Where in level 3, it comes into the process definition, which is into organizational level, the process deployment in the organizational level. So process definition, standard processes, process framework sessions, process metrics. So the standard process definition, sequence and interaction, identify roles and responsibilities and competencies, infrastructure and work environment, methods to monitor the process. So wherein the process deployment says like process tailoring, process management, skill management, including trainings, resource management, including skills and competencies, applied process metrics. So it level 1 is talking about there's an individual project. Level 2 is talking about there are set of projects but in project level, but level 3 talks about the organizational level. So process capability determination or the measurement framework. So we have already discussed like level 0, level 1, 1.1, level 2, 2.1 and 2.2. This is already discussed before in a pictorial way. So process capability determination. So there this diagram particularly shows the relationship between the process assessment model and the process reference model and measurement framework. So what is the difference? What is the relationship between them? Is like there is a graphical representation. So where like you can see there's like the process reference model talks about domain and scopes, and process purposes and process outcomes. Measurement framework talks about the capability levels, process attributes, rating, scale, rating method, aggregation method, and the process capability level model. The process assessment model talks about process capability indicators and the performance indicators. So the process capability determination. So we have 4 different categories called NPLF. NPLF is N is not achieved, P is partially achieved, L is largely achieved, and F is fully achieved. So for not achieved, it is 0 to 15%, and for partially achieved, it is 15 to 50%, and for largely achieved, it is 50 to 85%, and fully achieved, it is 85 to 100%. So based on that, like we will give the score to the particular process area on the for the capability levels. So once the particular process area achieved level 1, then it will go to level 2, then it will go to level 3. If any of the process area which is failed in level 1, it can't be a level 2 process area because it is already failed in level 1. So coming to the ASPICE concepts. So if you look at this diagram, so we have 2 different things like system level and the domain level. System is a combination of software engineering, hardware engineering, and mechanical engineering concepts. So all together, these three together will form a system. So this is a plugin there is this plugin concept. So wherein like we have all the domains which together will form as a system engineer. So we have terms called element, component, unit, and item. If you look into the V model, so all the left side uh, items, left side things are called as elements, and the right side things are called as items. So for the left side things are into development or are requirement, design, and unique construction, but wherein the right side things are, it's about the verification activities and the testing activities. So the development or the associated requirements design terms are called as element, wherein the testing related activities are called items. A software component consists of one or more software units. The wave is pushing in a way like it's pushing the wave, it's pushing the equipment more hardly than the actual capacity. It is keep on vibrating up and down, up and down. So as a result, like the wire of the crane it may tear it off, or it may break the entire equipment, so which involves a lot of cost. So because of that, we have kept a simulation there, and we try to bring in, or we try to analyze the impact of the operating environment in the real scenario. So coming to the next concept is traceability and consistency. Traceability and consistency is that the two different things, but traceability refers to why do we require traceability. So it is the linking between our work products, thereby further supporting coverage, impact analysis, requirements, implementation, status tracking. So we can easily find it out, like when you look into the traceability, if something is not completed, then you can easily track it off. And wherein the consistency is, it addresses the content and semantics. So it's like further bidirectional traceability has been explicitly defined between test cases and test results and change requests and work products affected by these change requests. And overall an overview of bidirectional traceability and the consistency is depicted in the next slide. Okay, traceability and consistency, if you see here keenly, so bidirectional traceability is indicated some in green, in sea green color, and the consistency is indicated in the maroon color. If you observe in detail, yeah, I kept quiet because you can observe this diagram, the stakeholder requirements, or this system requirements, or these how these are internally connected, and how we have to establish the bidirectional traceability and consistency. So coming to agree and summarize and communicate. So it is the term agreed means it's a joint understanding between affected party and uh, the content of the work product, which is like who's author of that, or the both the affected parties. Like if there is a contract in between, then that is called the agreement. Wherein like summarize and communicate is like they are talking about the results. So it summarize refers to abstracted information resulting from test execution made available to all relevant parties. So an overview of these aspects is shown in the. So this is as I said, like we have agree and summarize and communicate two different things. Agreed is like system requirements, design, and these all things like detailed design and coding. We have to communicate and we have to agree upon the freezing of that. But wherein like we have to summarize and communicate the results of verification and the testing activities, in whether it is integration testing or the qualification testing. We have to summarize the results and we have to communicate the results. So evaluation. So what is evaluation? Evaluation has to be done according to defined criteria. Such evaluations like evaluation criteria may include quality characters like modularity, reliability, security, usability, and these all things. So you can see the definition there. So wherein the verification criteria is the verification aspects will be covered in the verification, whether it is covered or not, we will see the verification criteria. Verification criteria of first software unit verification ensure compliance of the software compliance of the source code with the software detailed design and non-functional requirements. Possible criteria for unit verification including unit test cases, unit test design, unit test data, coverage goals and coding standards or guidelines, for example MISRA guidelines. And for unit testing, such criteria shall be defined in our unit test specification. This unit test specification may be implemented, example as a script in an automated test bench. So what is compliance? Compliance is with respect to the criteria. So what it is referring to is like with an architectural design means that the specified integration tests are capable of providing that interfaces and relevant interactions between the software units, software items and system items fulfill the specification given by the architectural design. So this particular diagram shows a relationship between evaluation, verification criteria and ensuring compliance. So if you see this particular diagram, so you can see the evaluation which is mentioned in SWE3, SWE2 and SWSys3 also, and wherein like you can see the verification criteria which is in between system requirement analysis and the qualification testing, system qualification testing, system architecture design and system requirement analysis to software requirement analysis to software qualification testing is the verification criteria set up there, wherein compliance is set up for each and every V phase. Like the compliance is to be established in between system requirement analysis and the qualification testing, and the compliance should be there in between the system architecture design to system integration and integration testing, and the compliance to be established in between software requirement analysis and the software qualification testing. The compliance is to establish in between software integration testing and this software architectural design. And the compliance is to be established in between software unit verification and the software detail design and unit construction. So it's some things are represented in the dotted lines with this SUP2, that is verification. So the relationship between strategy and plan. So I can move on to the next slide so that you can get the understanding of these two things. So strategy is like define the strategy, like how you are going to address it, how we are going to how you are going to address it is the strategy, and how you are going to implement it is the plan. So the strategy is something high level and the plan is something low level. So capability level 1 talks about the strategy, then the capability level 2 talks about the plan. So here is an example of the process area which I have taken is quality assurance process area. So there is a process ID, process name, process purpose, process outcome, best practices, and output work products. So it's actually like this is the output work products. There it is mentioned, it is like 3 6 3 5 6 and all, right? So you can refer it in the best practices, and you can refer it in the on the outcomes as well. So that's it for today. Thank you so much for your time, and thank you so much for your efforts. Bye.